Hey Karu, I just watched your video about your last weekend or your trip to the Women's US Open. Sounded like fun. Glad you went. I'm glad it seems to have improved your game. But you start with a low bar. Anything might improve your game. Of course, I know nothing about golf, so just taking a shot because a shot's there to be taken. I did want to mention that the previous video I put up I made unlisted, but only because it had extended footage of my granddaughter, and I wasn't sure how my son and his wife would feel about me putting extended footage of my 2-year-old granddaughter on the internet available to everyone. So yeah, that's why that video was unlisted. Looks like the roasting space is coming together well. I'm glad. Nice to see that. I like the customer space. You put a lot of time and effort into that. Looks real good. I promised in the last video that I wanted to do a video about AI. And so this is that video. I've taken some notes. As you know, we've talked about this a lot previously, but I've been doing a lot of reading and listening to podcasts and interviews with people and talking to people I know about AI. And I thought I just wanted to talk about it. So I'm going to talk about it for a little while here, and you can ignore it if you like. You can fast forward through it. You can not listen. To start out with, I want to say that, the discussion of AI is so imprecise, and what we're really talking about for the most part is large language models, LLMs, and I guess you've got models that reproduce images. I don't know what they're called. I haven't looked into those particularly, or video. And the interesting thing is that all of these types of models are, as I've said before, they're really good at mimicking certain products of human creativity. And the interesting thing about the large language models is that I actually went and read a paper by, and some summaries of, a paper by the guys at Google who basically in 2017 published this paper called "Attention is All You Need." And it's about this new technique that they employed that basically created this huge leap forward in large language models. And what they were doing, they were working on a program for translation from English to German. And it's these next word models where it tries to predict what word comes in a sequence. And my understanding, which is admittedly not strong and high level, is that what they did was they created parallel processing of pattern recognition, and at multiple stages they would kind of jump back and look at the larger context within which words were being predicted to try to increase the, and when you think about what translation is, you have to understand the context. It's not just, this word for this word. You have to understand the context and place it and predict which words in what order convey the idea. And so in their training data, they looked simultaneously at the more granular context and the larger context, and like I said, this is very simplistic, my simplistic understanding, having read the article and not being an expert. And when they employed this, they found that not only did this model improve translation, it also improved sort of interpretation of a text, or summarization of a text. And in some ways, you can understand why that would be, because the tasks are quite similar. Basically you're rephrasing something in a in different set of using different set of words, using different language. So it's not surprising that the model that does a good job at restating something from one language into another language can also restate something from one language into the same language with slightly, different parameters. So the that's my understanding of like this big breakthrough. And so the interesting thing about that is that this model does some things really, really well. And of course, the first is translation. And I think one of the podcasts I watched talked about how Google has now rolled out just recently real-time translation between English and Spanish, both directions, in their video chat software, so that the AI will produce if I'm speaking in English, it'll produce a Spanish language translation in real time, mimicking my voice for the person on the other end to interact with. And it does that quite well. The second another example of what these LLMs do really well is writing computer code, which once again is not surprising when you think about the idea that it came out of these efforts to build automated translation software, because you are just translating from natural language into a structured language, which in some ways should be easier. And of course, it's training on a set of training data, and it's particularly helpful and useful for that. And the third thing is actually the summarization, and so if you have sort of a verbose discussion written, poorly written, or like in this case, like my video, if you took the transcript of it, which is not very focused and honed, and plugged it in, and you could say summarize this. The large language models are good at that. They're good at kind of cutting the chaff. For example, my dad sent me just yesterday sent to all of us kids a 5-page letter about the state of he and my mom, which, my dad's a writer. He likes to write this kind of stuff. And I plugged it into Gemini and said, summarize this with a list of action items grouped by who is responsible for those action items. And it came back with a really nice list that then I sent back to my dad, and he thought, because I tend to be very critical of AI, he thought I was joking when I told him that, or I was mocking him when I told him that Gemini had produced this list. But it did, in fact, and it was useful, a useful list. Having read the entire text, it produced a reasonable summarization that was categorized in a way that was easier, and it meant I didn't have to go do that, which was what I was gonna do. So that's what AI does really, really well, and those types of tasks are useful. There's places we can use those. Now, the promise of AI, unfortunately, is largely driven by money. And what we see, I think, now is the application of trying to take, because we're so impressed with how good large language models are at those fairly limited tasks, that we want to apply them to everything else. And everyone wants to make money off this. So, it's like, oh, it can write books now. It can produce, the image production model can produce artwork and graphs and stuff. And it's like, but, the reality is that it's not good at, the software is not good at answering questions accurately, and coming up with thoughtful interpretation. It can just summarize things in ways that it already kind of can find patterns of in the training data. So the and so much of the promises of AI are driven by people trying to make money off it. So they want, people see this image generation stuff as a way to, now I don't have to pay an artist to do that. I can just generate an image. And the reality is that the value of having those images is sort of the uniqueness of it. And if you can just generate it out of nothingness, pretty soon, having in the past you could have an image with your article or with your whatever to differentiate it. Now, the ability of AI to generate that isn't going to differentiate you at all. So it devalues that. And you're still, if you want to differentiate yourself, you're still going to have to go to a manual artist, who can draw something that differentiates yourself. So I think in the long run, maybe that will improve the quality of the art. Google actually, one of the things I watched was a video on what's his good Marcus Brownlee's channel, and he's talking with all of the guys who work with him. There's like 5 of them talking, and the title of the video was "Google AI is getting really good" or something like this. And when I watched it, this was where they actually talked about the real-time translation that I mentioned earlier. But basically, they're like, oh, it makes these videos that, and every time they had a conference where they rolled out this stuff, and every time there was a speaker, they had an AI generated video of that person that came up in the background, and it looked so good. You can kind of tell it's AI, but it's really good. And they can actually do video now where they sync the audio with the person talking, and it's really good. And I'm like, they're all demos. All this stuff that they're showing are demos. And of course, you can always produce a good demo. So I'm not necessarily convinced. But the funny thing is that these guys who are all pro AI, they were saying, one of the things they said is it seems like the only thing that AI is good at is fooling people into thinking what they're seeing is real when it's not. And I think there's some truth to that at this moment. And the idea that somehow that's going to extrapolate to general intelligence, I'm going to get to that later, but I think it's a huge overreach. And part of that is like these same guys in this video were talking about how the Gemini search tool in Google sucks. Actually, one of them said, if you ask it a question, it never gives you the right answer. And the other guys pushed back on that. And the guy clarified that, well, I've been trying to work with Android for the first time in years, and I kept asking Gemini how to do something in Android, and every time it gave me the wrong answer. It told me go to the menu to this place, and there was no menu there. It gave me answers that were wrong. And of course they're like, oh, well, that's because there's different versions and it's drawing from different. But the truth is that another guy said, yeah, I really miss being able to use Boolean searches because I got really good at how to ask Google to return information I needed with Boolean searches. And I wish there was a way I could just switch Google to let me just do the Boolean search again because it's so much more effective and saves so much more time. It's more precise. And I think that this speaks to the fact that, once again, because this stuff is all driven by money, everyone wants to sell AI now. There's a huge bubble in value associated with AI. Now, in addition, there's someone I know, who I'm not going to name because I don't want to get this person in trouble, who works for a big company and is a content designer, or not a content designer, essentially a user interface designer. And I talked extensively with this person, and they're involved in AI. And the company they work for is implementing this certain user interface, and they're all in with AI. And this person's boss told them, we're building the plane as we're flying it. And and the task that they're trying to achieve with this is something that AI should be good at. But this person told me, essentially, AI doesn't do any of this stuff well. And what we're doing is we're programming it procedurally in the background and making it look like AI is doing it, but we're telling the AI exactly what to do. And so it's really not capable of doing what they're promising. And so, it's this overpromise, underdeliver. And so this person is trying to get out, actually has already requested a transfer and is transferring out of this, and says, I don't want anything to do with AI because it's going to be a massive failure. And I found that really interesting as well. And I think this once again applies to this idea of general AI, and what it's good at and what it's not, and this huge overpromising driven by an attempt to make money off of it. And the in addition to all of these kind of more down in the dirt discussion of what AI does and examples of using it and people who have interacted with it, I've also been listening to Roger Penrose recently. And it's interesting, Roger Penrose, if you look him up, he's a Nobel award-winning, I think he won a Nobel Prize in physics, but he's a mathematician, theoretical mathematician, I think. And he talks about, he wrote a book called The Emperor's New Mind that's really about consciousness, but it's relating consciousness to computability and artificial intelligence. And the program I took at Evergreen was called Computability and Cognition. And it was the idea of artificial intelligence programming. And like I said, we read Gödel, Escher, and Bach. And turns out Roger Penrose, he invented the drawing technique that Escher uses in the Endless Stairway painting or drawing. And it's funny because Penrose talks about this. He said he saw some of Escher's early work and it inspired him to think about how to represent three-dimensional shapes in ambiguous ways. And he invented, they call it, I think the Penrose triangle is what it's called. And he invented that, which then his father showed to Escher. And Escher, or his father drew a stairwell like the one that Escher used in his painting and showed it to Escher, and Escher then drew that drawing. So it's interesting, that kind of circular way in which Penrose was inspired by Escher, and then Escher ended, his most famous work came out of Penrose's application of Escher's ideas. Anyway, all of that is to say that what Penrose talks about in The Emperor's New Mind and in a lot of his lectures is the idea that what is computable, and what tasks are computable and what tasks aren't computable. And we see this constantly in discussion of AI, conflating consciousness with intelligence or computability. And those three terms are not all the same. And so one of the things that Penrose talks about is Gödel's incompleteness theorem. And the idea about Gödel's incompleteness theorem, or there's two theorems there, is that you can't have a logic system that is both complete and internally consistent. So there's going to be internal inconsistencies in your system of logic. And because computability is based on logic and converting everything to symbolic representation and sort of applying first order logic to it, there is a limit to the level of understanding. So let me back up and say, so Gödel's incompleteness theorem basically says, I think the statement is, this logic system cannot prove this statement. And that's the statement you feed in. and it's a paradox, because if the system can't prove it, it's true, but it can't prove that it's true. If it can prove that it can't prove it, then it proves that it's true, but it's not true. Therefore, this, and Gödel, posts this in just a, he represents this in a mathematical formula that's essentially, but one of the things that Penrose talks about is that our ability to understand what's happening there hinges on us not being part of that logic system. It hinges on us being an outside observer. And so because of that, if we're trying to program intelligence in a system, you need to be able to remove yourself from the system in order to make sense of what's true and what's not, and understand what's meaningful and what's not. And it's this paradox that many people have asserted, is a limit. It's this idea, and Penrose talks about consciousness, and he says, we know that our thinking, there's consciousness, and then there's computability, and we don't even understand how anesthetics really work in the brain at this point. We understand how they shut things down, but why is it that the computational functions of our brain continue to function when we lose consciousness? Obviously there's evolutionary, you can talk about that, but we don't understand. So what is consciousness? That we, it's clearly not the computability, and it's that self-awareness or whatever, and we don't really understand it. And all of this crazy optimism about sentience, and how I constantly, in my reading and in watching lectures, and there's tons of people talking about AI, and they all say it's not now a question of if machines will do all cognitive functions better than humans, it's just a question of when. And it just seems like hubris to me, because of this. And all of these things, the funny thing is, you don't hear anyone talking about computability, and Roger Penrose, is like this minor figure who's kind of shoved off in a corner because no one wants to. He's a 90-year-old guy, actually, and he did a panel on this just like a couple weeks ago. Really interesting. Anyway, it's just interesting to think about all this stuff, and once again to see. I think there's a tremendous amount of hubris in the way people look at this stuff and think about it. And every time we have a leap forward in capabilities, we're like, we've solved everything now. It's all behind us, and I think it's typical. Anyway, sorry this video has gone on for now over 23 minutes. I'm going to end it there, but I find it interesting to think about this. If you're bored, like I said, maybe you didn't watch any of this. That's my story, and I'm sticking to it.